Have you ever held your hand over a pot of boiling water? You probably couldn't keep it there for long, but when you put your hand alongside the same pot, it feels perfectly fine. Why does that happen? Because of convection. There are three types of heat transfer: conduction, convection, and radiation. Convection is a type of heat transfer that can only happen in liquids and gases because it involves those liquids or gases physically moving. Convection happens when there is a difference in temperature between two parts of a liquid or gas. The hot part of a fluid rises and the cooler part sinks. But let's use an example to think about why it happens, lest we assume that the fluid has a mind of its own. After a day of good, solid learning, it's time for a break. You put the kettle on to make a cup of tea. The kettle heats the water from the bottom, giving the molecules near the bottom more kinetic energy, movement energy. This extra movement allows the molecules to spread apart a little. If they're more spread apart, then that means the water is less dense. Cold water is generally denser than hot water. If you put something less dense inside something that is denser, what happens? Well, try putting a cork underwater. You won't be surprised to see it jump right to the surface. In this same way, the hot water at the bottom of the kettle is less dense than the cold water above it, so it will rise to the surface. Once it gets there, it cools down again because it's further away from the heating element. This causes it to become denser and sink. These movements of the water are convection currents, and that's why boiling water moves around so much. The water heats up and becomes less dense, then it rises and cools, becoming denser again until it sinks. This process repeats over and over, and it all happens due to a simple temperature difference between the top and bottom of the kettle. So just a minute ago, I asked you why it's so hot above the boiling pot of water when it's perfectly comfortable to put your hand next to it. Convection currents are the reason for this. It's because heat rises. When you put your hand next to the pot, you're receiving energy through other types of heat transfer, like conduction and radiation, but not very much. However, above it, you add convection into the mix. The heated air is literally rising up towards you to reach your hand. Convection is probably the most complex of the three types of heat transfer because it involves chaotic fluids, but there is still an equation we can use to represent it. This equation describes the heat energy transferred to a surface in an area where convection is occurring. The coefficient of convection is just a number that represents the properties of the materials involved, and the temperature difference is the difference in temperature between the surface receiving heat energy and the average temperature of the liquid. It is not the same as the difference in temperature between the top and bottom of the liquid. So, for example, let's say you have a pot of 97 degrees Celsius boiling water with a lid on it, and that lid has a surface area of 0.1 meters and a temperature of 67 degrees Celsius. This means there is a temperature difference of 97 minus 67, or 30 degrees. The convection coefficient is 20, and you want to know how many joules of energy is transferred to the lid every second. To calculate this, you would multiply 20 by 0.1 by 30, giving you 60 joules per second. Let's take a look at some examples. One example of convection is the weather. Warm fronts are less dense than cold fronts, which means they'll rise above them. When that happens, the water vapor in them can cool, condense, and fall back to Earth as rain. Cool sea breezes are caused by convection too. In the summer, the air above land becomes hot more easily than the air above the sea. When this inland air heats up, it rises, convects, and the sea air flows in to fill the gap. Convection even happens inside the Earth. In the outer core of the Earth, the liquid metals are hotter near the center of the Earth and cooler further out. This causes them to flow around in convection currents. These liquid metals contain charged particles, and their motion creates the Earth's magnetic field. The magnetic field of the Earth is important. Without it, compasses won't point north, birds wouldn't know how to fly south for the winter, and there would be nothing to push away dangerous radiation from the sun. Without the Earth's magnetic field, and therefore without convection, we wouldn't be able to survive on Earth. It even gives us a beautiful nighttime display called the Aurora Borealis, or Northern Lights. Convection happens when there is a difference in temperature between two parts of a liquid or gas. Convection is where the hot, less dense part of the fluid rises, and the cooler, denser part sinks. This cycle moves heat upwards. This is why heat rises, and why your hand gets hotter above a pot of boiling water than next to it. The equation for convection is this. Examples of convection include the movements of liquid metal in the Earth's outer core, which gives us the magnetic field, and certain weather effects like sea breezes and some sources of rainfall. Without convection currents, it would be hard for us to survive on Earth.